So in the software chapter, in today's session, we are going to see one more important system software, that is language translators. And in this particular chapter, these are the important topics. Okay, so first we are going to see what exactly is a computer language, what are the different type of computer language, and what exactly is a language translator along with their types. Okay. So the very first and the very basic one is a computer language. So as you know, a language is a mean of communication between the two parties. Similarly, a computer language is basically a set of instructions or the command through which one can communicate with the computer. Okay, so it is similar to the language what we are talking right now, but instead we are going to have such thing so that a computer, a dumb machine, a hardware can understand. Okay, basically a computer language is designed in such a way that human can write a program so that it can be executed by the machine. Okay, and a very popular terminology is the source code, which is basically a original program which is written by the programmer in a computer language. Okay, so if I am writing a program for suppose addition, so that code is known as source code. Okay, and there are three type of language: machine language, assembly language, and the high level languages. Okay, and all these languages need some language translator, which is a system software that we are going to see in the upcoming slide. So the first one is the machine language. So machine language is only language which can be understood by the computer CPU. Okay, and if you talk about high level language or the middle level languages, those level languages cannot be understood by the machine. The only language it can understand by the computer is machine language. And what does this language contain? It contain only binary 1 and 0s. So if you see this thing, so this is one language, it is binary language. Okay, and it is considered as a lowest level language, programming language, and which consists of 1 and 0. Okay, and each 1 and 0 represents something for the computer. The good thing is that for this particular language we have direct control over the hardware. So if you are able to write this program in the term of 0 and 1, you can directly control the hardware with these zeros and 1. And since it is very closer to the machine, it can execute those instructions very fast. And the very important one, you need not to translate anything. Okay, so no translators are required. But if you talk about the drawbacks of machine language, it is very hard to read. So if you see this program, I cannot understand in fact what it is written. Okay, so they are very hard to write and understand and debug. And all these machine language are very machine dependent. Okay, because they are written for a specific machine. Okay, so those are machine dependent. Example is this one. So if I show you, this is my one instruction in the machine language, you cannot make it out anything. Okay, but if you are hardware programmer, you can easily identify what does this mean. Okay, so based on that, one new language has come, that is called assembly language. Okay, it uses English like codes which are normally called mnemonics. Okay, normally called mnemonics. Okay, so mnemonics are English like codes. So if you see here, like HLT stand for halt, add stand for addition, sub stand for subtraction, STA stand for store a register. Okay, and if you see the code, this is the code. So there is a drastic difference between machine level language and the assembly language. So in assembly language we have English like code mnemonics instead of binary 0 and 1. And advantage, you can clearly see that now I can easily write a program and understand and debug, and I don't have to be worried about the address, okay, since address will be stored in the form of mnemonics. But again, the drawbacks are that it is machine dependent and should know the hardware knowledge, okay. And language translator is also required, because the only language which can be understood by computer is machine level language, so translator is required, okay. And if you talk about x86 assembly, ARM assembly, this is one instruction for moving the content from B to A, that is mov command, okay. The next level language is high level language. It is the topmost, where it is written like English like statement. So if you see, this is one code which is written in C language, so it is very easy to understand what it does, and you can easily understand, you can easily debug this program, and it is machine independent. So the program which you have written for this particular PC, you can execute it on other PC unless you required some translator for that. And this is the used by the programmer to write the software. And obviously, since it is written in high language, and it needs language translator to convert into machine level language. And there are many examples like C, C++, Java, Python. All these are high level languages. So we have seen the classification of software, application software and system software. We have seen operating system, general purpose operating system, specific purpose operating systems. So now it is translator. So there are three types of translator that we are going to cover right now. So the language translator, as I told you, it is a type of system software which translate a program which is written in one programming language to other, okay. For example, if you talk about assembler, it is going to convert assembly language into machine level language. Interpreter and compiler, these are written in high level languages, and it is going to convert them into machine level languages. So the first one is assembler. It is a system software, a language translator. So what it is translating? It is translating assembly language program into machine language program so that a computer can understand and execute, okay. And this pointer was asked in SSC CHSL. Example are Microsoft macro assembler, GNU assembler, okay. The next one is a compiler and interpreter. Again, these are types of system software, that is language translator, and the basic difference between the compiler and interpreter is based on the translation method. So in compiler, it is going to translate the entire program which is written in high level language to machine level language at once before execution. This is very important, okay. So whether it is a compiler, whether it is an interpreter, it is going to translate the program into machine level program, okay. But the translation methodology is different, okay. Compiler is going to translate the program at once, whereas interpreter is going to translate the program line by line, and instruction will be executed immediately, okay. And if you talk about execution speed, generally compiler speed is faster than the interpreter speed. And error detection, basically it is done after compilation, whereas if you talk about interpreter, it will throw an error at the first time when it got an error, okay. And in compiler case, there will be some executable file or object file will be created with which it can be executed, but in case of interpreter, no separate file or executable is made. It is executed directly just after one line, okay. Example are Python, okay, and C, C++, Java are the compiler. Whereas if you talk about Java, it is a mix of both, so you can ignore this, Okay, so Python is purely an interpreter where C and C++ are the compiler based.